In this example, we're solving a quadratic inequality. In order to test values to see what works, first we have to make sure that one of the sides equals 0. So first thing we're going to do is subtract 3 from both sides. And make sure your quadratic is written in descending order. So you've got 2x squared minus x minus 3. Then you're going to factor the quadratic however you like to factor. I'm going to borrow the 2. And I'm going to then factor into x times x to make x squared. And then negative 3 and positive 2 will make negative 6 when you multiply, but negative 1 in the middle. And then I'm going to pay back the 2 that I just borrowed, which is going to make these factors 2x minus 3 and x plus 1. And then what we need to do is we need to think about a number line and figure out what is going to work in each interval. So what we see here is that we're looking at these two factors are less than 0. So if you set them equal to 0, you're going to add 3 and divide by 2. So that would be 3 halves. You're going to subtract 1. So negative 1. Now this says that it is less than 0, not equal to. So that means on our number line, we're going to have an open point at negative 1 and an open point at positive 3 over 2. So it is not equal to in those areas. From there, you're going to make a little chart and you're going to test your factors. So my two factors are 2x minus 3 and x plus 1. And we're going to test in these different intervals, looking at your number line, where is this quadratic less than 0 is what we're looking for. So the first interval I see is everything less than negative 1. So I'm looking over here, everything less than negative 1. So that would be negative infinity to negative 1. Then the next interval I see is from negative 1 to 3 over 2. So we're going to list that, negative 1 to positive 3 over 2. And then the next interval is positive 3 over 2 to infinity. And so those are going to be the labels in my chart for each column. Then what you're going to do is you're going to pick a number in each interval and test it for your factor. So for example, negative 10 is between negative infinity and negative 1. So I'm going to plug in negative 10 for each x. So I would get negative 23, so it's negative. If I plug in negative 10 to the next factor, I get negative 9, so it's negative. Then I move on to my next column. 0 is between negative 1 and 3 halves. So if I plug in 0, I get negative 3, which is a negative. If I plug in 0 to this factor, I get 1, which is positive. In my next interval, I'm going to plug in positive 10, which is between 3 halves and infinity. So then I would get 17, which is positive, and I would get 11, which is positive. So then you're going to go down and you're going to put those signs together. So if you look at your quadratic, you are multiplying these factors, which means you're going to multiply the symbols together. So that would mean this is positive in that section of in that interval. This is going to be a negative times a positive is a negative in this interval. And a positive times a positive makes a positive in this interval. And we are looking for where is the function less than 0. So we want to know where is it negative. The only place it's going to be negative is in this section here. So then we would say, or if we go up here, we're going to only shade the interval from negative 1 to 3 halves. That is what makes this statement true. So we would say our answer is all x's in the interval negative 1 with parentheses on it because it's an open circle to 3 halves and parentheses because again it's an open circle.